Good day, math buddies! Sir Sherwin here, your math instructor. Welcome to another content where we are learning all about mathematics in an exciting and interesting way. And for today's video, we will learn all about direct variation. But first, please don't forget to subscribe to my YouTube channel and hit the notification bell for more updated contents. And I will be more glad if you will be liking this video, leaving a comment, and sharing this with friends. So just buckle up, relax, and all together, let us learn this mathematics lesson now. Dear math buddies, as what we mentioned earlier, today we will learn all about direct variation. And of course, these are the objectives we need to observe. First, we will define direct variation. Second, we will try to translate mathematical statements into equation. Third, we will be solving for the constant of variation. And fourth, we will solve problems involving direct variation. And to start, let us try to define a direct variation. Direct variation is a variation that occurs whenever a situation produces pairs of numbers whose ratio is constant. The following statements represent a direct variation. These are: y varies directly as x, y is directly proportional to x, and y is proportional to x. These three statements can be translated mathematically as y equals kx, where k is the constant of variation. So how will we picture out a direct variation? So it is just like your body inside an elevator. If the elevator moves up to the 10th floor, it means that your body is also 10 floors away from the ground floor. And if the elevator moves down to the 5th floor, it also follows that your body is 5 floors away from the ground. So if we represent the elevator and the body as our two related variables, where the elevator represents our y and our body represents the x variable, direct variation will give us the idea that when y increases, x will also increase. And when y decreases, it follows that our x decreases as well. So this would be the concept of a direct variation. This time, let us try to translate some mathematical statements into equation. Let's have the first one. The fare f of a passenger varies directly to its destination D. So in this certain problem, f that represents our fare varies directly to our D, which represents the destination. So mathematically, we can write this one as f equals kd, where k is our constant of variation. So f is equal to kd. Second, the cost c of a fish varies directly to its weight w in kilograms. In this mathematical statements, c represents our cost varies directly to our weight w. So mathematically, we can write this one as c equals kw, where k is the constant of variation. C is equal to kw. Let's have the third one. The employee's salary S varies directly to the number of days D he has worked. So mathematically, we can write S, that represents the salary, varies directly to the number of days D. So we will have S is equal to KD. Again, K represents the constant of variation. Let's have the fourth one. The area of a square varies directly to the square of its side. And this certain mathematical statement, A, that represents the area, varies directly to the square of the side s. Take note of this idea. There are two words that represents square. The first word, square, represents the figure, while the second word, square, represents a number multiplied by itself. So mathematically, we can write our equation as a is equal to ks squared. So our side must be multiplied to itself, or we can have it in terms of exponent 2. So a is equal to ks squared. This time, let's try to solve for the constant of variation and determine the equation of a direct variation. Let's have the first example. Y varies directly as x. Y is 28 when x is 7. So with this given statement, finding for k can be done first by translating our statement into equation. So y varies directly as x can be translated as y is equal to kx. Since our y is equal to 28 and x is equal to 7, all we need to do is to substitute this from our given equation. So we will have 28 is equal to k, that would be unknown, and x, which is 7. Since we are solving for k, we need to divide both sides by 7. So we will try to divide both sides by 7, eliminating it on the right side, leaving variable k on its side. While simplifying 28 divided by 7, so we will have a result of 4. This means the constant of variation is equal to 4. So after we determine the constant of variation, finding for the equation of a direct variation can be done by substituting our k to the existing equation. So that is y is equal to 4x. So this would be the equation of our direct variation. Let's have the second example. M is directly proportional to n. M is equal to 200 when n is equal to 300. So how will we determine the constant of variation? Again, let us try to translate our statement into equation. Since m is directly proportional to n, then we can write this one as m equals kn. So by substituting our m, which is 200, and n, which is 300, we can now solve for our k. So we will have 200 is equal to k times our n, which is 300. So we need to divide both sides of the equation by 300 as we eliminate it on the right side, leaving constant k on the right side. And simplifying 200 over 300 can be written in terms of fraction as 2/3. And of course, we can write this one in terms of decimal, which is 67 hundredths. So this is now our constant of variation. And to determine the equation of the direct variation, again, all we need to do is to substitute this k in our existing equation, which is m is equal to 2/3 n. So this would be the equation of the direct variation. So let's have the third one. So how will we determine if the table of x and y represents a direct variation? If we still remember the definition earlier, direct variation occurs whenever a situation produces pairs of numbers whose ratio is constant. This means if we will get the ratio of x over y or y over x, it follows that they must be equal. And if the ratio is equal, then our given table of x and y is considered as a direct variation. Supposing our given table represents a table of y varies directly as x. So if we will have y is equal to kx, Finding for the constant of variation can be done using the ratio y over x. So that is, when we divide both sides of the equation by x, then we will have the ratio y over x. So if we will have the ratio y over x, so determining for our k, it can be done using y, which is 3 over 7, 6 over 14, and negative 9 over negative 21. So if we will try to check if our ratio is considered to be equal, then let us try to simplify the given fractions. So 3/7 is the simplest form, while 6 over 14 can be written as well as 3/7, and negative 9 over negative 21 can be written as well as 3/7. We notice that our x and y has a constant ratio, which is 3/7. This means the constant of variation of this given table of x and y is 3/7, and it represents a direct variation. So this is how to determine if the given table of x and y represents a direct variation or not. So just get the ratio of our given x and y. This time, let us try to solve problems involving direct variation. Let's have the first one. If y varies directly as x, if y is equal to 12 when x is 4, find y when x is 12. So how will we determine the value of our y in this certain problem? So first thing we need to do is to translate our statement into equation. Since y varies directly as x, then we can write this one as y equals x. So this would be our solution. Y is equal to kx. Then, using the first set of given, if y is equal to 12 when x is 4, substitute these values in finding for the constant of variation. So if our y is equal to 12, k is unknown, x is 4. Our task here is to solve for k. So we will have to divide both sides of the equation by 4. So here, constant of variation is the quotient of 12 and 4, and that is 3. So the constant of variation is 3. So after we solve for our k, or the constant of variation, that is the time we will find y when x is 12. Remember, we are now solving for the value of our y when x is 12. For us to solve for y, all we need to do is to utilize the equation we had a while ago. That is, y is equal to kx. So, finding for the value of our y can be done if we will have the value of our k, which is equal to 3, and our x, which is equal to 12. So, that is y is equal to 3, and our x, which is 12. So, getting the product of 3 and 12, we will have 36. This means our y is 36 when x is equal to 12. So, this is one way on how to determine the unknown value in this direct variation problem. So, let's have the second example. If y varies directly as x, if y is equal to 3 when x is equal to 10, find x when y is equal to 1 and 2/10. Again, for us to solve for the unknown variable in this given equation, first thing we need to do is to translate our statement into equation. So if y varies directly as x, this means it can be written as y equals kx. So using the first set of given values of our y, which is 3 and x equals 10, substitute this in solving for k. So again, we will utilize the first set of given in solving for k. So we will have y, which is 3, and our x, which is 10. Again, we need to divide both sides of the equation by 10 as we leave k on the right side. So our answer for the constant of variation can be written in terms of fraction, which is equal to 3/10. Or we can have it in terms of decimal, which is 0.3, or again, 3/10. So after we solve for our constant of variation, this is the time when we will solve for the unknown variable using the second set of given. In this case, y is equal to 1 and 2/10. So all we need to do in solving for our x, so again, using the equation y is equal to kx, or y varies directly as x, substitute our y, which is 1 and 2/10, our k, which is in terms of fraction, which is 3/10, and our x, which is unknown. Then, solving for our x can be done first if we will apply cross multiplication as we multiply 1 and 2/10 by 10. So we will have 1 and 2/10 times 10 is equal to 3x. So 1.2 times 10, we will have 12. That is equal to 3x. Then because we are solving for x, we will divide both sides of the equation by 3. So we can cancel out 3, leaving the variable x, and quotient of 12 and 3, that is equal to 4. So this will be the value of our x when y is equal to 1 and 2/10. So with this, let's try to have our third problem. The amount of paint P needed to paint the walls of a room varies directly as the area A of the wall. If 2 gallons of paint is needed to paint a 40 square meters wall, how many gallons of paint are needed to paint a wall with an area of 100 square meters? This problem involves direct variation. And for us to solve this problem, let us apply the concept we had a while ago. First is to translate our statement into mathematical equation. In this certain problem, it states that the paint P needed to paint the wall varies directly as the area A of the wall. So mathematically, it can be written as P equals KA, where P represents the paint needed to paint the wall, and A represents the area of the wall. So using this equation, we will solve for the constant of variation, or our K. So using the first set of given, which is 2 gallons of paint, and the area of our wall, which is 40 square meters, substitute this in our equation as we solve for K. So P, that is 2, K is unknown, and the area of our wall, which is 40. Then, we will try to divide both sides of the equation by 40. Cancel this out. K, here, K is equal to 2 over 40, or it can be simplified as 1 over 20. So this would be the constant of variation. And after we solve for the constant of variation, this is the time when we will solve for the unknown using the second set of given. That is area of a wall, which is 100 square meters. To solve for P, that is P is equal to KA P is equal to the constant of variation which we solved earlier, that is 1 over 20, times our area using the second given, which is 100 square meters. So to simplify, 1 over 20 times 100, that is 100 over 20. And 100 over 20 can be simplified as 5. This means a 100 square meters wall needs 5 gallons of paint. So this is how to solve a problem involving direct variation. So remember the steps we had? First, we will try to translate our statement into equation. Second, solve for the constant of variation using the first set of given. And third, solve for the unknown variable using the second set of our given together with the constant of variation. Hope you understand this concept and can be applied in your problem solving. But then again, please don't forget to share this video with your friends and your classmates for them to learn also. There you have it. Hope you learned something new today. God bless us all.